from the PDA, that is push down automata TOC. Push down automata TOC. Um, so this question is the language of the following PDA would be. This is the June 2024 exam, first exam question, June 18th question. So the language of the following PDA would be. Some transitions are given here. So we have to find the language which is accepted by this PDA. So before that, we have to know about what is PDA, that is push down automata. The push down automata is different from the deterministic finite automata, that is used for accepting the regular languages, but the push down automata is used for accepting the context free languages. So it is used for implementing context free languages. What is the difference between finite automata and push down automata? DFA and push down automata means in DFA and NFA there is no memory involved in this. So, but in the case of push down automata, it has extra memory. It has extra memory which is called a stack for storing the values, for storing the alphabets or input values, for recognizing the context-free languages. So, what is the push down automata? Here the PDA. How we can define the PDA? So here some symbols are used in PDA definition. That is Q, capital Q, which is the set of states. Sigma, which is the set of input symbols. Then tau, it is the set of push down symbols which can be pushed and popped from the stack. That is stack alphabet, which is also called stack alphabet. Then Q naught is the initial state. Z naught or Z is the initial push down symbol which is initially present in the stack. So initially stack contains this Z value, Z or Z naught. Then F is the set of final state, and delta is a transition function that maps Q into the transition function. Delta is a transition function. Then in a given state, the PDA will read the input symbol and stack symbol, that is top of the stack. Based on this input symbol and the top of the stack, the next state will be decided in the PDA, which means we have to take the current input symbol and top of the stack. Based on these two values, we have to change the state of the stack in the PDA. So this is the process involved in the PDA, the definition of PDA. So here the problem is the language of some transition functions are given. We have to find the language for this. We have to find the language for this. So this is the process involved in this. Okay, first one, initially a stack has Z naught. Initially a stack has Z naught. Here some transition functions are given. Here what is means by this represents the transition function. The first one represents the current state. The second one represents the current input symbol. The third one represents the top of the stack. So when the transition function like this, that is initial state is Q naught, the input symbol is A, and the top of the stack is Z naught, then the corresponding output state will be, the transition change will be like this, Q naught, which means the next state stay in the current state itself. Here the current state is Q naught, the output transition is also Q naught, which means stays in the current state itself. Then the input is A and the top of the stack is Z naught. Then we have to push 3 A's into the stack. That is the problem given here. That is 3. We have to push 3A into the stack. So the output is Q naught comma triple A Z naught. Z naught already in the stack. When the input symbol A is coming, we have to insert 3 A's into the stack. So the next transition is Q naught comma A comma A. Already three A's are pushed into the stack. Now the top of the stack contains A. So the input is A and the top of the stack is A. The input is A and the top of the stack is A. The transition is then it also stays in the current state, that is Q naught, and the again three A's are pushed into the stack. Again three A's are pushed into the stack. So already the stack contains, the top of the stack is A. So apart from this, three more A's are pushed into the stack. Three more A's are pushed into the stack. The next one is, next transition is, initial state is Q naught, the input is B and the top of the stack is again A. Then the next transition is, the corresponding transition is Q1 comma lambda. Lambda here is empty. So the Q1 comma empty. Now only in the third transition only the output state is changed from Q0 to Q1. Q0 to Q1. And here the B is coming. When the input is B, then we have to pop the stack. We have to pop the stack, top of the stack. So the top of the stack is already A. So we have to pop one A from the stack. So that is given here. When the input is A, three A's are pushed into the stack. When the input is B, single A is popped from the stack. This is the concept behind this transition function. The next is another one function, transition Q1 comma. Now the state is Q1. The input is B and the top of the stack is A. The input B means then we have to pop. So it stays in the same current state, that is Q1, that is empty, which means the A is popped from the stack. So the next one is Q1 comma no input. In the current state is Q1 and empty, which means there is no input. Then the top of the stack is Z0, which means all A's are popped from the stack. All inserted A's are popped from the stack. Then we reach the final state, that is QF. QF is QF indicates the final state of the transition function. So here that is the concept here is, when the input is A, three A's are pushed into the stack. When the input is B, the single A is popped from the stack. So here I have given step-by-step process for this value, and the corresponding diagram, PDA diagram here is, so the first one step, initially a stack has Z0, that is empty. Initially stack is empty, which means which contains Z0 value. So the stack contains Z0. The top of the stack pointing to Z0. Okay, next transition, the given in the problem, that is this value. This is the next transition given in the problem, which means Q0 is the current state, input symbol is A, top of the stack is Z0. Then we have to stay in the current state and insert three A's. And insert three A's into the stack. Already the stack contains the Z0. Already the stack contains the Z0. Three more A's are pushed into the stack. So this is the value. So here the second step is, input is A, top is Z0. Then push 3A into the stack. Now the stack contains, already the stack contains Z0. Now three more A's are pushed. So A, Z0. And there is no change in the transition. That is, it has to stay in the same current state itself. So the corresponding figure is given, diagram is given, that is Q naught. The input is coming from this in the initial state, that is Q naught. It has to stay in the current state itself. So the one arrow is given like this. The corresponding output is, sorry, the input is A. Then the first one represents the input symbol. The next one represents the Z0 is the top of the stack. Then what is pushed into the stack? That is given in after this slash. Three A's are pushed into the stack. Already the stack contains Z0. So here what is stack after this transition? Z0. That is the value. First step diagram. This is the first step diagram. That is, it has to stay in the same state itself. the input is A, comma, the top of the stack is Z naught, then slash, we have to give some symbol, slash, then push 3A's into the stack. This is the second step. Next one, third step, the third transition is the initial state is Q naught, current state is Q naught, and the input is A, and the top of the stack is also A. The top of the stack is also A. Then the output must be, it has to stay in the current state, and three more A's are, the input is A. So we have to insert three more A's into the stack. Already the stack contains, the top of the stack is A. So the second diagram for this Q naught, it also has to stay in the current state. Q naught itself. So in this arrow itself, we are writing the next transition. The input is A, and the top of the stack is A. Then three more A's are inserted into the, pushed into the stack. So already the top of the stack is A. That is mentioned here. So now three more A's are inserted into the stack. Then the next one is the next step, that is Q naught comma B comma A. This is equal to Q1 comma lambda, which means now the transition is changed from Q naught to Q1 in the output. Next, the input is B and the top of the stack is A. Then we have to pop. When the input B comes, we have to pop A from the stack. So that is given here. That is given here from Q0 to Q1. Q0 to Q1. That Q1, the transition is changed. So you have to write the transition in this arrow. B is the input, comma. A is the top of the stack. Then we have to, nothing is inserted, which means here the value is popped. Top of the stack is popped, that is indicated like the lambda symbol here. So which means B is the input, A is the top of the stack, then we have to one A is popped. So the next step is step 5. The next step is step 5, that is Q1 comma B is the next input, B is the input, and A is the top of the stack. Again we have to pop the stack value because the input is B. But in this time it stays in the current state itself. So here, so we are putting the arrow like this. Then B is the input, then A is the top of the stack, then slash lambda, which means A is popped from the stack. Nothing is inserted, nothing is pushed, only it makes the pop operation. So the next one is, so after popping, then what is the stack contains? Now two A's are popped from the stack. Now the stack contains this value. So the next one is step 6. The another transition is Q1 comma empty comma Z0, which means suppose no more input in the string means, then the stack only contains the Z0 value, then it reaches the final state that is given here from Q1 to QF. It moves on to the QF, that is the final state. So the input is empty, the stack is, top of the stack is Z0, and there is nothing is pushed, so it only contains the Z value. So this is the transition diagram for this PDA. When we see this, transition given in the problem, the what is the, for every A, for every input A, three A's are pushed into the stack. For every input B, single A is popped from the from the stack. So the concept here is, the problem is when n equal to 3, n equal to 1. For example, n equal to 1, then only one time it will be work there. Then in single A is the input, then B is 3 into 1, that is 3B. So when the input A comes, 3 A's are inserted into the stack. 3 A. When the input B comes, 1 A is popped from the stack. For single A itself, it inserts 3 A's. For every b value, one a is for. So here three a's are given. For three a's are inserted for every a value. So the answer is a power n b 3 power n. A power n b 3 power n. We can simply find out this 3 power n, 4 power n, 5 power values are given. The value should be like this, 3 years. 3 means 3 years, 4 means 4 years. That is the simple small logic involved in this operation. When we given the language like this, when we given the language in some other different form, this is not the case. So here the 3 years are there, so it may be in the 3 is the 3 b power 3n. So here the answer is the next option, third option, a power n b 3 power n. So when n equal to 1, the input is a, the b must be 3, so that we can push and pop the corresponding input in the input using the PDA. So this is the answer for this. So another one question involved in the TOC is in the recent year is for the regular languages and context free languages, which is not correct. Which is not correct. Both are closed under union operation. Both are closed under concatenation operation. Both are closed under intersection, then complementation, then clean star. So these are the options given for this question. So based on the regular languages and context free languages. So here the closure properties of regular languages. For this question, we have to know about the closure properties of regular languages and closure property of context free languages. So here that is union, intersection, difference, concatenation. These are the various operations involved in the regular languages. Then for CFL, these are the various, what are the operations are closed under this CFL and what are the operations are not closed under this CFL. So based on this, the regular languages are closed under all the properties union, intersection, then concatenation, complementation, and clean star. But the closer CFL are closed under union operation, concatenation operation. So the first two options are correct. Then the intersection. CFL are not closed under intersection, that is given here in the not closed property. Then and CFL are also not closed under complementation, not closed under complementation. Then both are closed under clean star. Clean star not given here, but both are closed under clean star. So the CFL is not closed under intersection and complementation. So the options C and D are the incorrect statement. C and D are the incorrect statement. So that is the answer.